Cool, recording is on. Good morning, everyone. Let me mute everyone as well. Okay, I know I'm not showing my screen yet. Let me show you my screens. Okay, today's topic, the first half is going to be mainly talking. First an hour and a half probably. I'm just going to talk about some project management techniques. Okay, so we have been doing software projects for the last, how many, 25, 30 years actually in the software industry, or maybe more than that. We have made so many mistakes, and then we have learned so many lessons out of it. What are the mistakes that we made? What are the lessons we have learned? And what is a new way of doing software projects is mainly the first half of the that's my objective for the first an hour or some first an hour actually. So traditionally what we have been doing for the last at least 15 years is, so when you get a project, it doesn't matter whether it's a financial project or auto industry or a simple software product or anything. When you get the project, the first thing you want to do is you get the requirements for that. Okay, so what am I delivering? What is the expectation of the users? So I'll get the project requirements. So I typically get this, in any enterprise scale project, that the requirement gathering itself takes about 3 months. So I get the requirement gatherings and then, including my architecture team, architects and the project, and say, hey, this is the problem domain. So what do you think is the solution domain? So how do you think we should approach? So that's when I'll actually bring in my solution architect and others into picture and say, this is how it looks. And the whole team as well, if required, tech lead and all the other folks, say, okay, how do you tackle this one? So how do you think we should go about it? So we'll kind of design the whole project. So what patterns we should use, how many layers we should have it, what's a strategy for this one, everything about it. That is called designing phase. So we have the requirement phase and the designing phase. And then once the designing is done, that designing will be given to the development team and say, developers, and it's us. So it will be given to the development team and say, okay, based on these principles, based on these design decisions made, there'll be some reasons why we made those design decisions, right? There'll be some thought process behind that. So development team will go and execute that. That typically takes long time, actually, 3 to 6 months. And then once the product is completely developed, and then QA team comes into picture, testing team comes into picture, and they say, okay, we'll test this whole piece. So generally they test it, functional testing, regression testing, all sort of testing. They do it very rigorously. They want to break the system. Well, sometimes, yes, that's their goal. They want to break the system so that these bugs don't appear in production. Rather, we get them in lower environments is the biggest goal, right? So testing happens for another 3 months and bug fixes, everything cool. Finally, testing team says, you know what? Everything is good. Product is good. Let's go ahead. And then the deployment team comes into picture. Of course, roles overlap here. People who developed could potentially work in deployment team as well. People who developed could potentially work in design team as well. So it's roles overlap. Whoever gathered the requirement could be in testing too. So roles overlap. So the deployment comes to the picture, and they talk about the strategy for the deployment. Where do we deploy it? What are the servers for this one? What do we do? how many servers we need, how many Apache front end we need, what's the clustering strategy, what's the everything, whatever. All they take another couple of months, and they say finally deployed. So typical life cycle is like this. So you have requirement gathering. You can't see it. Oh, can you see it, Tom, and everyone? Can you see this one? I just started drawing actually. I wasn't drawing earlier. So this is the requirement gathering, and then it generally lasts for 3 months or something, and then another design phase, and then there's a long development phase. This is development. Okay, so after development will be testing, and then deployment. Here, requirements gathering, design. So if you look at the timeline, this is how typically this goes. Typically around 3 months requirement gathering, 2 months design, 4 months development, 3 months testing, probably 1 month for deployment, 13 months. What happens typically is in the requirement gathering itself, here they say, hey, we want to, for this particular project or for this particular product, what are the expectations, what are the requirements that we need to work on? So they gather the requirement for every single, they gather the details for every single requirement for the whole project. So here they got probably this 200 features. They say, at this point, business analysts generally sit with business units and say, hey, what are the requirement gatherings? So they got list of items to do, like 200 items to do. So they'll work on the requirement gathering, design, development, testing, deployment. At any point, business user comes and say, around testing area, this area, hey, dude, hey, the team, hey, I have a very critical requirement right now. Hey, can we add this one to the project? No. You can't add the requirements in between. Your phase is done and your role is done. Your phase is only this 3 months. You cannot add new requirements once the requirements are gathered. Once we start the design or development or testing or deployment, that's all. You are stuck. You have to wait until the whole deployment is done. Then you will take this as a special service request, and then I treat it as a different item, and then I'll do it. But business user says, hey, this is more important than what you're doing. Hey, you are working on some UI changes to, you're making it look better. But this is very critical. Without that, even if you launch the product, there is no point. Well, I understand that, sir. But sorry, you can't do it. That's how it works. So the biggest problem with this point here, with this approach is, you can't add the requirements in between. So there is no agility in this process. So you can't be agile in this process. So there is no agility. Two. So you gathered 200 requirements, right? So you delivered those 200 requirements. It doesn't matter whether you take 13 months or 16 months or 20 months. Your goal is to deliver these 200 the requirements. And you will not deploy your product even if you are not done a single requirement here. You took these 200 requirements and you're taking that as your goal, and your goal is to deliver all those 200 requirements to production in one go. So there's no in between, either done or not done. There's no in between, either 200 done or 200 not done. There's no in between. So how about that? There are 200 requirements. I'm sure in any project, if you have 200 pieces of requirement, not every requirement has the same priority. I'm sure no project in this world will have the same priority for all those 200 items. No business users will say that I don't accept the product without delivering all these 200 items. All these 200 items have the equal priority. Absolutely, that's not possible. But unfortunately, we're doing this way. And the another biggest point is, it's a whole software development is a big game, right? I mean, once you get the product, see here, after this 13 months or 20 months, if you look at a financial institute which waited 13 months to deliver its product to attract the customers. So probably if it waits for 13 months to deliver this whole project, the time to market, it's losing the time to market, and it's that product does not have or may not have any value after 13 months. If I had delivered this product within that 3 months itself, it doesn't have to be 200 requirements, but at least, 2-3 top priority requirements, if I just deliver it to the public, and then I can start earning some money here. But in the other case, I was trying to be perfectionist, but it's too late. It takes 13 to 20 months before I see my baby. But I don't want that. Rather, prioritize all the requirements that you have. Take the most prioritized item. Okay, if go back to your business user and say that, hey, I understand you got your 200 requirements. Okay, you want us to knock down these 200 requirements. Very good, got it. 200 pieces of tasks. Tell me the priority of all these 200 items. So which one of them have the topmost priority that I can't deliver the project without them? And then most of the business users will say, okay, I can live with it on day one with these 5 items. They say that. Okay, so deliver those 5 items only. Take a couple of months and deliver those 5 items, and then they will understand. They're feeling the product now. It's going to the customer, and then they'll get the immediate feedback. They get the quick feedback. But here you're not getting the feedback until it gets completely delivered after 13 months or 20 months. By then it's too late. By then you're obsolete in the market. Unfortunately, it's too late in the game, because your competitors came in, and of course they don't have as many items as you do, but it doesn't matter. You compare your Microsoft Word versus Google document, Google Docs, right? Microsoft Word has apparently like 200 or 2,000 features. Okay. So if you look at it, Microsoft Word has around 2,000 features, and out of 2,000 features, apparently only 20 of them, 20 features are used by 95% of the people. The other 1980 features are used by 5% of the people. But Microsoft Word has taken all these 200 items, okay? They gathered the requirements, they designed, they developed, they pumped in billions of money, and finally after 2 years, they delivered with all the 2,000 features, no problem. But Google Docs, they're smarter. They just delivered the top 20 features within just 2 months. Of course, this Google Docs is not for everyone. Not this for 5% of the people who absolutely need these other 1980. That's totally fine. But I'm actually targeting these 95% of the people within 2 months. So I'm marketable. I can market my product within 2 months for these 95% of the targeted customers. I don't care about these 5%. So what essentially Microsoft is getting is this one. So for these other 5% of the people, it has delayed the total project for 2 years or 1 year, 10 months, whatever it is. Otherwise, it would have delivered these 20 items in just 2 months. Ooh, did you see that? So that's where you have to embrace the agility. So this is called, typically water drops like this, right? From top to bottom. And if when water flows, this is how it flows. So this is how we typically do the project. This is called waterfall methodology. This is called waterfall methodology. Methodology, probably G. E. This is called waterfall methodology, and this has this is how we have been doing projects for the last several years. But unfortunately, it has these problems. There's no agility. I cannot add the requirements in between. Okay, and no quick feedback cycles. I have to wait for the whole project to be done to taste my product whether it really works or not. So I will realize if my project does not work, I will realize at the end of the project that, oh, my bad idea, that doesn't work. So I realize here. Why don't I realize here? Early failure is what I'm looking for. Make me fail early. Don't make me wait all the way until the project is done and then tell me that it's a failure. Come on. So there's a new wave of thinking came into picture recently, just around 5 years back, 6 years back. It actually started 10 years back. No, it started 10 years back, but it took momentum around 5 years back. That is called agile methodology. I'm not sure whether it's O or E here. So it's called agile methodology. What agile methodology says that there are multiple flavors inside agile. We'll talk about it in a few minutes. But the agile principle is be agile. The biggest point here is be agile, meaning embrace the change. Be agile meaning embrace the change. At any point, if your business user comes and says that, dude, whatever you are working on is not the top priority, but I just got in. because I just got a new requirement from Fannie Mae or new requirement from US government saying that we have to be compliant with this rule. So we have to get this going right now. You can't say that, okay, wait until the project is done, then we'll do it. You can't do that. Keep whatever you're working on the shelf and then start working on this one today. Absolutely. I'll embrace the change. I'll do it. I'll do it right now. Okay? Since you're saying this is the top priority. 2, collaborate. So earlier in other waterfall methodology, what we used to do is, your development team is different, your design team is different, your testing team is different, your deployment team is different, requirement gatherings are done by someone else. So if I have a question regarding this requirement, then I send an email, and then it goes to chain, and then, probably by the time my whole email, the whole question gets answered, it will be weeks, days. But here, Agile methodology says that semantics are not important. Rather, getting your work done is important. Collaborate. Okay, let's cram all of us, all these cross-functional teams. Let's sit together in one single room. They took this idea to extreme, and they say that every single one of you should sit in a single room and a single table and a big table. Generally, they call it agile rooms, war rooms. So you just sit there and say that your business user will be sitting there, business analyst will be sitting there, your tester will be sitting there, your developer will be sitting there, your architect will be sitting there, your deployment guy will be sitting there. So all of you are talking to each other. You're doing more as a team than individual silos. So here, we used to do more like an individual silos. Hey, I'm a development team. I don't talk to you. Hey, I'm a tester. I don't talk to you. But in this approach, in the agile way, everyone is part of the team. So be agile, collaborate, and then quick feedback or fail early. If you need to fail, failing is not bad. Failing is never bad. You can learn a lot of things from failing. Okay? But the problem is fail early. Don't tell me after 20 months that the project failed. Tell me after 2 months it failed. It doesn't work. The idea doesn't work. Okay? So you'll get quick feedbacks, right? Meaning, I'll explain what this one is. So we were doing, the biggest point is this one. So we're doing requirement gathering, design, development, testing, and deployment in a serial fashion, one after the other, one after the other, one after the other, in a sequential way. We were doing it. So what we do in Agile is this one. So we take all these 200 items, 200 requirements. We don't take actually. We don't spend 3 months on the 300 requirements. What we ask business user is, hey, do you have list of things to do? Yes, I do. Okay, can you prioritize them right now? Prioritize them. Prioritize each and every single task. Okay, and then she will prioritize and say that, hey, you know what? This is the prioritized list. 1, 1, 1, 2, 2, 2, 3, 4, 4, 5, 5, something like that. Okay? And I know now. At any point, the goal in Agile is, at any point, you'll be working on the topmost priority item. So you'll always get the biggest bang for the buck. So you'll always get the big bang for the buck. So 1, 1, 1. So I'll take these top priority items and say that, hey, I will deliver these top priority items. So product owner, okay. I'm getting into this too much jargon. Business user says that, hey, my project can't be delivered without these 3 top priority items. After that, we can add one change, each change as you move forward. Absolutely. Okay, I'll take those 3 items. So what I do is, this is how I work. Rather than working in silos over the months, what I do is, I will deliver the software in quick intervals, quick short intervals. Those short intervals are as short as 1 week. Generally, these intervals last for 2 weeks. So within this 2 weeks, so this is just 2-week interval. I say that within this 2 week, I'll deliver this first item or second item or third item. I'll say that within these 2 weeks, I will gather the requirements, the detailed requirements for those top 3 items, and then I'll do the design, I'll do the development, I'll do testing, and I'll do deployment. We're not talking about 2 months now, 2 weeks. So within these 2 weeks, but what I'm not doing, earlier, I took all those 200 items, but now we're only taking 1 or 2 items. I'll take but that 1 or 2 items, I'm not picking them randomly. I'm getting them from the prioritized list. So at any point, I'm only working on the top priority items. That's the most beautiful thing here. So within these 2 weeks, I'll gather the requirement only for those 1 or 2 tasks, and I'll design, development, test, and deploy, and then push it to production. So users are getting taste of how the product is going to look like. Okay, this is for another 2 weeks. Now I'll do 1 more 2 weeks. So we are not looking at all these phases as different, distinct phases. Rather, we are actually combining all of them into a single cycle, but we do more cycles. This is 2-week cycle, and I'll take 1 more 2-week cycle. This is cycle 1. This is cycle 2. Yes, they call it sprint cycle. Oh, is that Prasad? Not sure whether it's okay. Yeah. So this is small cycles. In some cases, they call it sprint cycles, but cycle 1, cycle 2. Okay. Again, in this cycle 2, I take the second most priority items. So here again, I'll gather the requirements. I'll design, development, test, and deploy. So I'm doing the same cycle again, and I'll take 1 more cycle. I'll do the same thing for maybe within just 3 cycles. These are all 2-week cycles. 2 weeks here, 2 weeks here, 2 weeks here. So after 6 weeks, we got done probably 5 or 6 items here out of 200 items. And then your business took a look at it. Hey, you know what? 6 weeks back, we thought the product will look like this. But somehow, after 3 cycles, we looked at it. We got the top 5 or 6 done. And we delivered to customers. Our customers are using it. And then for some reason, the feedback that we are getting from our customers is, this is not what we're actually looking for. You know what? Industry has changed its priority. This project actually doesn't work. We thought in the beginning of the project that it would work, but it doesn't work. You know what? It doesn't work. Hey, let's scan the product. Absolutely. Go, let's scan the product. So after 6 weeks, business user felt that it doesn't work. Let's scan the project. So you're scanning the whole thing. The total project has been scrapped. It's a very good thing. It's an excellent thing. You have to look at that way because of these quick intervals, user got very quick feedback. Within 2 weeks, he was getting feedback. So he got feedback here, he got feedback here, he got feedback here. So within that feedback, he's being agile. So he's thinking now, hey, is this what I actually wanted on day one? No, I don't think so. Market is making shift to different, it's going in a different direction right now. It's not priority right now. No, government has passed a different rule and, let's not work on it. Okay, let's scrap this. So what did it lose? Well, it lost just 6 weeks worth of the team effort. How about here? You don't know that until the whole project is delivered for all these 200 or 2000 items within just 13 months or 20 months. You don't get the feedback until the whole project is done. That's the most disastrous thing with this traditional waterfall methodology. But here, you're getting quick feedback. You can make the decision. You can be agile at any point and change the direction of your ship as you go. Change the priority of any of these items, the items that are not done, based on the market conditions at that point. So you're being more agile. You're embracing the change every single phase. The requirement gatherings, you are embracing the change. Design, you are embracing the change. Same thing works for design too. You don't go for this big architecture up front. You just learn as you go, learn as you go. You just don't assume and develop this big component that you would use. Everyone probably will reuse that. Don't build like that anymore. Be agile and think smart and think logically. And then there are no individual silos anymore. Requirement gathering, design, development, testing, everything is a cycle. Within the 2 weeks, everything has to be done. Of course, what you're getting done is very tiny bit, but that tiny bit, you're not picking randomly, rather you're getting it from the prioritized, the list of items to do. So these prioritized items, the prioritized things to do is called product backlog. Now we talk about some jargon, product backlog. Okay? And each cycle is called, in some flavors of Agile, they call it iterations. So the cycle, in some flavors, they call it iterations. And in some flavors, they call it sprint. And there are predominantly two flavors for Agile. In fact, 3, it started coming up recently. There are 2 flavors mainly. One is called XP, Extreme Programming. I'll write here otherwise. XP stands for Extreme Programming. The other one is mainly Scrum. This is what people are using mainly, Scrum. Some principles are different. Some terminologies are different. And XP is more for developer centric. So what developer has to do using XP, typically XP focuses on developer. Scrum focuses on the total project management. So everyone is using Scrum nowadays. Of course, you gather some principles of XP, you combine them. In most of the companies, you will see the combination of XP and Scrum. Okay? So some people call it iteration, some people call it sprint. Scrum terminology is very important. Sprint, they call it sprint. And then the other one is every single day they look at, when I take this 2-week iteration, we want as quick feedback as possible, right? So one guy is working on requirement gathering for these 2 weeks. Design, one guy is working on design, development, testing, deployment. So maybe I'm a developer and I ran into some issue. I need help from my lead or anyone else. There is no lead. There is no, all these fancy roles anymore. Everyone is same. Everyone is part of the team. Okay. Team wins at the end of the day, not an individual is the main goal there. So I raise my hand and say, okay, dude, I'm running into this issue. Can any of you had a similar issue before? Can you help me, please? Okay. Another one will pitch in, and because we are all working in the same room at any point, no emails, no fancy stuff. Okay. And if you have an idea, okay, take a small whiteboard and then say, okay, this is my idea. Okay, how about your thoughts? A business user will be sitting there, business analyst will be sitting there, architect, development, everyone. Pretty cool idea, right? So, and apart from this one, every single day they meet for quick time boxed 15 minutes. Typically it's 15 minutes. You can set up your time. So they typically meet every single day. They don't sit on a big meeting hall or anything like that. It's called stand-up meeting. Everybody has to stand up because the tendency of people is once you sit, you tend to talk more. You tend to spend more time there. But if once you stand up, you'll be more, okay, let's get this done quickly. Everything has to be time boxed. So they just meet for quick 15 minutes and then talk about what did I do yesterday? What am I going to do today? And do I have any roadblocks? They just talk about these three items very quickly within 15 minutes, the whole team, and say, we'll get the quick feedback like, okay, well, what's happening? Oh, I took this task. It's going well. And another guy says, yeah, I took this task. This is what I'll be working on today. Hey, by the way, I ran into this issue. Did anyone run into that issue again? So we'll get into that discussion and try to help each other. That's what the goal here is. We get the quick feedbacks. So this is called product backlog. The list of items, prioritized items is called product backlog. And these daily meetings are called stand-up meetings. In most of these, these daily meetings are called stand-up meetings loosely. And some people call it daily sprint. Especially in Scrum area, they call it daily sprint. So the prioritized items is called the product backlog. So there is no such thing called scope creep anymore. So when business user comes in and says that, hey, I need to add this one, you don't cry anymore because you're only talking about 2 weeks, right? I mean, business user generally doesn't come in between those 2 weeks, but once this 2 weeks cycle is done, then he'll say, hey, you know what? I thought the other 18 items are topmost. Something is changed in the industry. I want this to be done in the next cycle. Drop everything, whatever you're doing, just do this one. Absolutely. By next cycle, I'm getting this done. So I'm always taking these market changes into consideration and being agile, and I'm always embracing the change. That's the most beautiful thing. You're always, if you have to fail, you're failing early. You're getting the quick feedback. Be agile, collaborative. And most of these people are actually doing agile nowadays. So I would highly recommend you try to read a little bit about Scrum, especially. There is a very good book called Project Management with Scrum. Project management with Scrum. It's a very good book. If you want to read more about it. Okay. From our developer standpoint of view, what we have to take is the biggest one is collaboration. We all must collaborate. So information shares, they call it info shares. If you guys know, share with each other. You share your knowledge, I'll share my knowledge, I'll share whatever I know. So there's no such thing called the superheroes anymore. Everything is team. So if I'm in trouble, you help. If you are in trouble, I'll help. And then one more important concept that XP has brought up, and everyone liked it, is called pair programming. The concept of pair programming is two developers will be working on a single machine. There will be only one keyboard, one monitor. So we both will be sitting next to each other. So one will be typing, the other one will be helping. So two pairs of eyes will be looking at the code, and two brains will be thinking on a single line of code. Okay, they'll be thinking, there'll be two different ideas, right? So that's always better than one. So they tested it, pair programming, and pair programming, I just love it. I'm telling you, I'm a hands-on developer. I just love coding. I know how pair programming works. I did it with a few of my good friends in my current company. Wow, it's awesome. What you get done is amazing. That's what actually I told all my other batch team members too. Work as a team. I'll leave this computer on. Actually, this idea, it's not my idea. I don't take any credit for that. One of my other students, other batch student, Jitin, he said that, hey, can you leave your computer on? And then we will use that as a collaboration tool. We all talk to each other. He took the lead, and here, one of you can take the lead. You just say, okay, I know this concept. I'll explain it to you. Or Meera was running into issues, and Kulsum jumped in and say, okay, I'll help you. And while she's helping, you can all take a look at it, and you pitch in and you put your ideas too. That's how we grow. If you want to learn everything on your own just by reading the books, you can only learn so much. But if we all learn and then share it, then we know so much. So there's no limit for that. So pair programming absolutely works. It's my favorite. The most important part now is testing. So back in those waterfall days, so developers used to think that testing, come on, that's tester's job. It's not my job. That's tester's job. I just code. Okay, whether it works or not, they will tell me whether it works or not. So I never test my code whether it works or not. So that's how it's called cowboy coding. That's how we used to code back in agile days. What these agile people have taken, one really good. This is the most important in my opinion for developers. They've taken the paradigm shift. So what they say is, We are not thinking in silos anymore. You are tester, I am developer, you are designer. We are not thinking like that anymore. We, as a team, if I have to wear my tester hat, I will do it. If you have to pitch in and do some development help for me, absolutely, you will do it. Though your role, official role is tester, you do that. That's why we are working together as a cross-functional team. That's the whole purpose of it, right? So they brought this important perspective into limelight. What they said is testing should be part of developer's job. I'm not talking about this whole big application testing. I'm talking about whatever the line of code that you are writing in Java, you make sure that's working right. So you test your code. That is called unit testing. That particular aspect of testing is called unit testing. There are so many kinds of testing. There are so many levels of testing. But the unit testing is your single unit of Java code is being tested, and that will be tested by you, the developer. So that's your responsibility. Unit testing is an integral part of your development. When you write a single line of code, you make sure that single line of code works. So actually, one of the agile members, one of the crucial members in agile team, one of the original ones 10 years back, one guy actually created a tool to do unit testing, and that tool is called JUnit. See, initially written for Java, and now it's there in every single programming language. C# has it. They call it NUnit, I believe. .NET has it, and Ruby has it, Scala has it, all the other programming languages. Everyone has this unit testing framework. So this is a unit testing framework called JUnit. I'll show you how to use JUnit today. It's a pretty good tool. Simple code. And when you write your code, how do you test it is a goal. You know what? They tested it. They were writing the code. They're testing it. They're writing the code. They're testing it. Very, very cool. Very cool. Everything is good. These agile people, they take any idea to extreme, right? So that's why they call it extreme programming initially. So what they did is, these XP advocates, what they did is, well, testing is good, but I challenge you folks to do something else. Let your unit tests drive the actual code. Meaning, don't write a single line of code before you write the test case. That's how you make sure you're writing the test. That's how you make sure you're writing the test, and that's how you make sure you are covering every single scenario. Try to understand that part. You are not going to write a single line of code without writing a test case for that. It's real extreme to the concept of unit testing. So before you write your Java code, you write a test class first. And what do you want to write? Okay, I want to code something. No, don't code it. What is your goal? Well, I want to write a calculator. Okay, don't write calculator yet. Do you have a test case? Okay, think about test scenarios. What is the requirements? Well, when user says 2 plus 3, I should give him 5. Oh, that's a requirement? Okay, write the test case first. So write the test case that when I give you 2 plus 3, then it should give me 5. Okay, very cool. Then what's the next test case? Well, it not only works for the whole numbers, the integer numbers, but it should work for others also. Like if I give 2.35 plus 5.76, then it should work too. Well, you write the test case. Okay, write the test case for that one, but that scenario, and then make sure, and then write the actual piece of code. Then change it in a small intervals. As your testing changes, you now make changes to your actual code. So you are writing a test class first, and then the test drives how you write the actual piece of code. That is why it's called test-driven development. So test cases are driving the development. That's why it's called test-driven development. Test drives the development. I write the test. If I write one more test case and it takes my coding this way, yes, absolutely. Now, at any point, I have the fully covered test cases. I have the test cases that cover every single corner case. Okay, we tested the whole numbers, and then we tested the decimal pieces. So you want to be able to support negative numbers also? Oh yeah, sure, test that scenario also. If you have to change it, change it. And then what else? Multiplication, division, and subtraction too? Sure, support, write it. First, write the test case, and then don't assume you will need subtraction, multiplication, and division also. Don't assume that you would need it, because that is why we are in this hell. We have been coding for the last 10-15 years, assuming that we would need one day. So we started building these components, reusable components. So we have been building the reusable components before it gets used for the first time. Can you believe it? We started building the reusable components before its first usage. Isn't it funny? So you always think big. That's what we have been thinking all this while. And there is a software principle called Agni. There is a software principle called Agni. You ain't gonna need it. It's not a principle, actually. It's a little satirical one. Agni. You ain't gonna need it. If you don't need it, don't do it. Don't assume you would need it tomorrow. Be agile and do it as per the requirements that you have today at this time. If your business user is asking for a simple addition of two numbers, don't just go build your calculator there. Don't spend time. She wants a single addition. Sure, build a calculator, but don't put anything but addition. When she asks for multiplication, then you do it. You ain't going to need it. If you don't need it, don't do it. That's one of the most, concrete principles of Agile. So they have taken this testing to another level, and they came up with this idea called test-driven development, TDD. Oh, it's a beautiful concept. So they say you have to test drive it. You test drive your code, meaning let tests drive the actual development of your the actual development. It's pretty neat. Test driving is fun. Okay, before we look at the unit testing, using JUnit, we'll unit test, and then we'll look at the test driving and all the examples. Any questions at this point? How is it? Is it interesting? It's pretty good topic. One of my favorite topics. Yeah.
Yes. Yeah. Can you hear me?
Yeah. Is that Lynette?
No, it's Tom.
Tom, 1 second, actually. Yeah, Tom.
Okay. Um, could you just quickly go through, the different uh, people involved in this? You mentioned architect. There's developers. I
Mm-hmm.
mean, we're getting training right now to be a developer,
Mm-hmm.
but what who are I guess my question is, just from top to bottom, who's involved in this, and what, you know,
Okay.
and what is their different skill sets, and why is an architect different than a developer, or why is a business analyst different than an architect?
Okay.
You understand what I'm asking?
I think so. I'll try. See, but one thing I want you to keep in mind, Tom, is this is a cross-functional team. Okay, you will never wear any hat and say that, okay, I'm a developer, I don't do that. You will never ever say that in Agile. Did you get that point?
Yes.
Okay. So I apologize if you get echo because of my speakers.
No. I'm on a Bluetooth headset now, so
Yeah, yours always because you hear on speaker. Is that right?
yeah. No, I switched over to a headset, but it's wireless. It's a Bluetooth
Okay.
headset.
Okay. So here, typically we have a business analyst. The main purpose of business analyst is to, it's multiple again, in some companies, they don't mean much. And, depending on the company, Tom, mainly, that's what I wanted to say. The role of the business analyst is to speaking with business units, mainly working with business units. Business units, these are the most important people. So the business units are the ones that fund money to the actual project. Okay, in a mortgage company, that will be like top level people. Or in some software companies, CTO will be your business unit. Okay, so these business users are very specialized in their skill. They know everything about the mortgage industry or financial industry or whatever the industry that you're looking for, or auto industry. These are very subject matter experts in their area. Okay. So, and developers, pure technical guy. Okay, come on, tell me what do I do here? Okay, I mean, I can understand. I mean, we have common sense too. We can understand, but we are very limited in that area. We have very limited knowledge in auto industry or financial industry or mortgage industry or anything. Okay, because we always like to code and we want to learn more technologies than more business. That's our nature. I mean, I don't get it wrong. That's what we are. I'll be proud of it. Okay. Excuse me. So business analyst bridges the gap between the developer and business units. And business analyst says that she will potentially know a little bit of both. She's not a developer, but she knows what you do. She's not a business user, but she knows what business users, what they want. So she tries to talk with these people and convert the requirements in a developer understandable way. So she'll actually bridge the gap between business units and developers. So that's business analyst. And this business unit, generally business unit is a team, but there will be one person that you'll be contacting to. That one person is called, in Agile world, it's called product owner. So product owner is responsible for success or failure of the project. So generally she's from business, not from IT. So business analyst, you understand, she will act as bridge between product owner and developer. And then loosely, there are other roles as well. These two are very loose. These two are very loose roles. Tech lead and architect are very loose roles. I'll tell you what they are. And there will be in Scrum, there is another role called Scrum Master. There is a role called Scrum Master, but generally one of these people will act as Scrum Master. The Scrum Master is the one who specializes the Scrum principles, the whole Agile principles, and leads the team in a way that the project is successful. If somebody has questions about the whole Scrum, hey, how do we do this in Agile actually? What's your idea on this one? Then he's supposed to know all those Agile principles, how to do it. And he doesn't have to be technical. Most of the time, Scrum Master is not technical. Business analyst most of the time acts as Scrum Master, but that depends. And then there is another role called QA, quality assurance / tester. This tester's role is typically to test the whole application. So for every single change that you guys make with each iteration, 2-week iteration, their goal is also to make sure that you're not disrupting the existing application. The existing application is there, Amazon.com. We already have that application. So we are all working for Amazon, right? So you added a new link somewhere in the product page. That shouldn't break something else in Amazon. So tester's responsibility is to make regression testing. That's called regression testing, to make sure everything else is also good along with this change. So, and also they do functional testing also, okay? And then again, depending on the company, business analyst, in some companies I've seen, our company also, business analyst can play the QA / tester role as well. And QA / tester can act as business analyst as well, depending on the size of the team, depending on the company, depending on the culture, mainly the culture, how they have been doing all this while. And depending on you, in some cases, if you step up, if you play two roles, then everyone will assume that, oh yeah, Tom is a smart guy, he can play that role. He's a developer, but he never says, this is my code and, this is your code. He always steps up and say he'll try to help each other. So if someone comes and say, hey, who is your lead? Hey, we don't have anyone as such, but Tom always fills that role. So let's call him tech lead. It's loosely very loose terms, tech lead. Architect, again, based on the company. Some companies don't have architect role actually. Some companies have architect role. Their role is typically, tech lead is typically a technical guy and who will mentor other developers and make sure, he'll try to remove the hurdles in the technical area for other people. And the architect is typically technical too. He should be sound and technical. Should be. That's what I'm saying. Some people are not technical, but architects are supposed to be technical too. Again, in architecture area, there are multiple solution architect and enterprise architect and all that stuff. So what their role is, again, company to company, Tom. In some companies, at least in our company, we have, architecture team like this. We have 4 people. We work for the whole floor, the whole IT team like this. So there are multiple silos, multiple teams here like this, right? The individual teams. What we do is we work with every team. So we have some non-functional requirements in goal. meaning we don't deal with how your business analysts say, business users say, okay, that's functional requirements, but non-functional requirements, meaning how our servers are responding, how our garbage collection is working, you know, uh, what's the security principle in our company, what's the componentize. If this guy is using in this team is smart, okay, we generally learn from other team members. This guy is smart, he did something. So okay, since we involve with every single team, we know that, oh, this guy is smart, okay, he built this one, okay, we get this idea, okay. We say, hey, how about reusing that? We come back, I'm architect for this guy, assuming, or Tom is architect for this guy, Anand Kumar is architect for this guy. And he comes back and say, discuss with the team, hey, you know what? This guy, Tom, did a pretty cool thing in this team. Maybe we should use this in other projects. Okay. So Anand Kumar comes and says, updates the rest of the team. And all these other people will go. And when I go to this team, I'll say, hey, these guys have the same issue. And then I'll say, hey, you know what? Other team had the same issue, and this is how we resolved it. Hey, let's use the same thing. And we have some common standards here, coding standards, all that stuff. We make sure that these all the other people are following this coding principles and everything. So that's how it works. But again, some companies don't even have these rules, and some companies are very strict about, architect never codes, architect designs it. Crap. Did I answer your question in a sort of loosely?
Yes, that's good. So the architect does the design.
What is that?
And the architect does the design.
Yes. Architect mainly, he's a designer, yes. Because architect would have had a lot of experience too, right? So based on his experience, when you come up with an idea and say, I should be able to say, hey, Tom, I had that same issue before. And if we do that way, unfortunately, we run into this issue. We had some garbage collection issue and servers went down, hey, come on. We have to keep, you always think, being a developer, you always think just the functional requirements. And being an architect, I always think in the non-functional requirements as well. Hey, Tom, your idea is not scalable. I come and say, hey, Tom, your idea is not scalable. You know what? It works for 100 people. If your site is accessed by 100 people, what happens if we are hit by 1 million people on a Christmas Eve? We are Amazon.com, so hey, we have to keep that into consideration. So we have to grow horizontally, so we have to be scalable horizontally. So I'll just throw some ideas, and sometimes they're crap, sometimes they're okay, sometimes, but it's again, based on you were architect. These are all loose terms. So you think like an architect, you'll be an architect. That's all. Think about non-functional requirements. Think about, whole coding standards. Try to think about tomorrow. And well, keep again about Agni principle also. You ain't gonna need it. Don't think too much too. Okay. In some companies, architects have very bad reputation.
Okay, good.
It's about experience, right? It's about experience. Some people are pretty good. Some architects are very good.
Who would you say, which role has the biggest picture? Sees the biggest picture from top to bottom.
Bigger picture?
Yeah, which role would you say it's the architect or the analyst?
Oh, two different areas, right? I don't even know what analyst would do actually. Analyst talks to business user. Being an architect, I'm just saying, business analyst talks to business users, goes, grabs the requirements. That's her pure area. She's very specialized in the mortgage industry. She's very specialized in the auto industry. She knows pretty much in and out of it. She'll be subject matter expert. She can talk to business users and say, hey, this is how, we should do it. Or business user comes and say, explain this one, and she will be little technical. She will know probably, hey, developer, I think, this is the requirement. Don't worry about what she's saying. She's talking very high level business user, but I'll tell you in a developer understandable way. So she doesn't know what I'm thinking. Business analyst doesn't know what I'm thinking. I mean, being an architect, my goal is to always talk about the coding principles, the coding standards, non-functional requirements. Where when you guys design, I would at least click in my mind that whether that works or doesn't work. Did I have any experience with that kind of design before, or can we use any design pattern there? Hey, maybe we can use this design pattern there. Use this one. So business analyst doesn't really understand what architect speaks or what architect is thinking, and architect doesn't always get what business analyst is thinking in terms of business. So it's two kinds of roles, right? So they complement each other. Always work in a team environment. So it's my specialty, thinking of about non-functional requirements, always looking at server scalability and all those things, and business analyst always looks at the functional requirements. So the combination of functional and non-functional requirements will work the best at any point. You know what I'm saying?
Yeah.
They're not replacing each other. They're actually they complement each other. Business analyst very purely into business, no technical, not even she can't write a single line of Java code. But we write a lot.
Okay,
but
that's good.
Generally, this is the in your career though, this is how it works. Developer goes to tech lead based on the experience, and generally after tech lead you get into this architect role. If you are interested, if you want to grow in technically, but tech lead can become manager if you're interested in management area, and eventually you can go into that. But the architect, and then here again another big area: solution architect, enterprise architect, and a specialized architect, security architect, data architect. There are a lot of roles again.
Okay.
So this is pure technical area. You know what I'm saying?
Okay. Mm-hmm. Yes.
So any other questions from Tom? Tell me. Go ahead.
No, I'm done. You can move on.
Oh, are you sure?
Yeah.
Oh. Any other questions from anyone? Nandakumar, do you have any questions?
Yeah, actually I have one.
Yep.
Until this recent conversation between you and Tom, trying to explain, I was thinking like architect has a main role. Now I'm basically what I'm trying to tell is basically I thought architect was a very important role, meaning say for example for agile methodology, out of 200 or whatever the total number is, we take the top 3 to do the work, right?
Mm-hmm.
Right?
Mm-hmm.
So basically say for example after 5 iterations, or basically after we did 9 tasks or something like that,
Mm-hmm.
and if there is some other new 3 tasks which are very critical and
Mm-hmm.
which needs a design change, so that's where the architect will be very critical, right? He's the one who makes a decision how it has to be designed, right?
Okay. I don't want to say that, Nandakumar, unfortunately. Being an architect, I don't want to say that. The reason is, these are all, again, based on the organization, these are defined sort of loose or tough terms, okay?
Okay.
It's a team that is responsible. An architect, yes, he's part of the team. You know what I'm saying? Always,
I see what,
though architect will have more experience in design area, but always team takes the decision, meaning, including the tech lead, because being an outsider, okay, I just come and you just explain to me and I can't make the decision. The reason is, I just propose it. Okay, this is how it works. Okay, this is the how about this design. Okay, this is how it works. You know, calling the web service from a trigger database? No way, man, because we would have seen various scenarios. You know, I've seen projects where projects crashed just because of some database triggers, you know, calling web service, you know. So we learned something in a hard way that you can't do that. So if you're designing in that way, I'll pitch in and say, no, that's not possible. You don't want to do it. And sometimes, yes, architect will have a bigger stick and say, yes, it doesn't work. You have to do this way because of whatever the requirements. Yes. In fact, that's true in some cases. You know, they'll have a bigger stick in technical design and say, you know what, absolutely, you have to do this way. This is good for the company, good for everyone.
Okay.
You know what I'm saying?
Yeah, I know what you're saying. Basically, I was having a different way of thinking on this one before. Now I think I got a different view of different perspective of analyzing this one.
Yeah, it's
Now, basically, I was thinking earlier, like, basically what I mean to say is, when they get 200 requirements, even though we don't do everything at one time, so looking at the basic requirements, I thought he was the guy who gives an idea, okay, this is the approach we should start going forward, which will be easier for us to
no,
enhance new additions to the existing product or whatever it is.
you are still mostly right. You are still mostly right, Nandkumar. That old thinking, whatever you're thinking, still mostly right. Because there are two kinds of arguments in the industry. You know, some people say that, I'll tell you both of them, okay? I'll send you one video also between Uncle Bob versus the other guy about the whole architecture thing. You know, some people say that in Agile especially that, okay, you think small, okay? You design for today, okay? So tomorrow if something comes up, well, refactoring, there is something called refactoring. I'm not sure whether you guys are familiar with it or not. Refactoring, meaning refactoring is nothing but once you write some piece of code, when the requirement changes or next time you touch the code when you're doing something, if it's not working or it's working but you want to improve the design of the code, so every single day as you touch the code, you have to refactor it, meaning you have to improve you have to improve the design of the code every single time you touch your code. That is called refactoring. So you have to keep improving your code. You don't get the pristine code. You don't get, golden code on day one. Okay? So everything in life, everything, good comes in life in multiple passes. So you don't get on single time, right? So you have to keep doing. So what some people argue that is, you always think small to start with. Don't think too big. Okay? And let architecture evolve. Let architecture evolve as you go through. Here you learned something new on the third sprint. Absolutely. You change your direction and change your architecture now. Again, in fifth sprint, again, you change your direction and change your view is one way of thinking. The other people, some people, what they think is you still need somewhat bigger architecture. Yes. Well, we are going to do that, Gunjan. We'll take a few minutes break, okay? So some people think that we need somewhat bigger architecture. At least at this point, you take a look at this one and ask some basic questions. Okay, so who are going to be the users? Okay, and how many users are you expecting? Well, today you say, hey, my application is going to get 10 users. Okay? And tomorrow you don't come and tell me that your application will be hit by 10 million people. Then you have to, design that way, right? So you get some basic idea and always keep that in mind and design it and architect it. Okay? Of course, I totally understand. I'm with the fact that architecture has to evolve rather than architecting with big picture on day one. I don't like architecting too big on day one. I'm not a big fan of that. Architecture has to evolve. I totally get that. But again, you sort of has to get the bigger picture of your application too. The reason you want to get the bigger picture of application is, I was listening to this video one day between Uncle Bob and another guy. So I'll probably send it to you if you find it. So if you don't think about it, right? So if you're thinking about bank account, right? So if you think about the bank account, so bank account, that account number is like 1234. Okay. If you don't think just bank account as a real account and architect that way, what do you think when you look at it? This is like a number. So account is a number. You can add, you can subtract, you can divide, you can multiply, you can divide like any other number. So you would architect in this angle. But this 1, 2, 3, 4, which is a number, happens to be a number, but this is a bank account. When you think this as a bank account, you will design it differently. So, well, in a typical bank account, you may want to transfer the balances, you accept something, you will get into this potential scenario like where, insufficient balance exceptions, that kind of stuff. You think that way. But as soon as you think this is a number, hey, bank account is a number. As soon as you think this is a number, that's all. Your perspective will change now. You start thinking about, you can add a number, this is like any other number. I can subtract, you can multiply. Come on, you don't think like that. So little bit of thinking is absolutely required on day one as well. That is why most of the projects in Agile, before they take any of this functional stuff, okay, before that, they take one complete cycle, they call it sprint 0. They take this sprint 0 and they think big here. Okay, what do we have to do? What do you think? Come on, here you don't, once you start the functional requirements, there you don't think about what repository, what configuration management we should use. Like, should we use CVS or Subversion or Git? You don't make this kind of decisions here. You have to make them upfront. So that's why I'm saying, so early architecture is still going to be required, but don't think big. Again, you will run into this Agni principle. You know what I'm saying?
Yeah, I'm getting it. Yeah,
I mean, it's all, there's no silver bullet answer, Nandakumar.
Yeah, I get it.
I mean,
yeah, I think anybody can win this argument. I do get it now. Yes.
Yeah. So take a look at this bank account example, right? If you think this is a number, you will design it one way.
Yes.
If you think of it as a bank account, if you step back and think a little bigger, then you will design it another way.
Yep.
Right?
Yep.
So,
Yep, I got it. Thank you very much, Venkat.
Oh, no problem, Nandakumar. I mean, anytime. Any other questions from anyone before we take break? Okay. So we'll take...
Can I, excuse me, Venkat.
Yes, Tom.
No, this is Leonid.
Oh, Leonid, sorry. I'm sorry.
Yes. I have a question about my homework, how to upload it. when we can fix it.
Okay. Okay. If everyone is on the same page as me, this is what I'm proposing today. Okay. Once we come back from, we'll take probably 10 minutes break. Okay. Once I come back, probably I'll take another 1 hour or 1.5 hours. I'll talk about, unit testing, TDD. We'll take a simple example and do it. Okay. From here onwards, we don't want to use public static void main. That's a goal. So I'll try to do that. And after that, I'll just give the floor to you guys. Can you help each other? I mean, it takes some from you, Can you people take the lead on that? I mean, Gunjan, Bala, Kulsum, Leonard, everyone, can you share that, Leonard having some issues and other people are having some issues. Can you help each other?
Yes.
Is that a good idea?
Yeah.
Yeah, I want to hear from everyone.
Yes.
Very cool.
Yeah.
Very cool. So you spend 30 minutes or so, 30 minutes to 1 hour, Not everyone is required, but please, this is a team effort. So try to help each other. And again, I'm telling you, teaching is the best way to learn. Okay. And if you don't know what to do, call me. Okay. I'm always here. So no worries. So I'll jump in if everyone is having issues. Okay. But this is, I'm giving you opportunity to help each other and help reinforce your concepts. Okay. Okay. So everyone is on the same page. Very good. And 9:40, we'll take 10 minutes break. So we'll come back and by 9:50. Okay. I'll stop the recording. Okay, I started the recording. Welcome back. Now we'll talk about unit testing, examples. Okay. Okay. So unit testing, right? So for unit testing, what we have been doing for testing was writing a public static void main. We wrote a simple car class and then car demo, sedan demo, overriding demo, inheritance demo. All these demo classes are typically test classes. That's where we actually instantiate it and invoke a method on it and verify the behavior. Well, we are not really verifying the behavior. All we are doing is system.out.println. So in a way, we are verifying it because we are looking at the console, what we are printing, whether it's really happening or not. That's okay. That works. But the biggest problem is, one, you have to compare only in console when you do system out printlns, right? You can't really check the behavior itself. When you say, in the calculator example, when I pass 2 and 3, I should check the result as 5, right? That's what my unit tests do. The second point is automation. Okay, before second point, probably the third and most important point is automation. The second point is you can have only one main method you can't have more than one main method in your class. So if you have to test two scenarios, then you have to write two classes or put those scenarios in just one single main method. You can't have multiple methods like this. Okay, I'm testing add functionality here. Test add. I'm testing subtraction functionality here. Test multiplication. You don't have anything like that, because you can only have one main method. And inside one main method, you can put everything. Either you have to do that one or create multiple classes. The third and most important thing is you cannot automate this whole thing. Meaning, if you have a framework where you write your test cases as individual, each test case is a single method, then I don't write main method on my own. Someone will call these test cases, and then inside my test case, I'll instantiate it and call the method, and then verifies the behavior, whether a test case is passed or test case is failed. Then someone else should collect that information and give me a nice graphical view saying, hey, this guy ran 10 test cases, 8 failed, 2 passed. And for each failed scenario, this is why it failed. And then this whole thing, I should be able to run it from a different, standalone server. This server, as I told you, that server is called build server. So that server, what it does is it grabs everyone's code in a regular intervals as part of the continuous integration. It grabs everyone's code from the standard repository, either it's CVS repository, Subversion repository, or Git repository. It gets everyone code and then compiles it, builds it, and then runs all these unit test cases, and then make sure that whole thing is good, and then deploys into wherever it needs to be deployed. So there is a framework to do this, to do everything, whatever I told you just now. There is a framework. There is a unit testing framework that's going to help us write better test cases in Java. That unit testing framework is called JUnit. Okay, so what we'll do is, the first thing, you're going to install JUnit download. Let's go to the website called junit.org. Okay, download JUnit. And then the latest version, whatever that one is, JUnit 4.1.10 source. We don't need the source code for that one. We need the basic jar binaries. Okay, let's show in folder. This is the jar file. Okay, probably I have not talked about the jar files. Let me close all this. So we have source code, our .java file, and then when you give the source code to Java compiler, you'll get that class file. This is called binary file, right? Okay. when you are writing a component, for example, Gunjan, he's good at something, calculator, okay? He wrote a perfect calculator in the world. So for that, he wrote several classes, several unit test classes, he wrote the best calculator ever. So all these classes he compiled and he got the .dot class file, and then he wants to give it to the public. He just wants to give it to open source world and say, okay, hey, I'm giving it for free. So you just go take it and just use it in your applications. Well, good. So what he does is, once he gets all these binary files, .dot class files, so he just zips all these .dot class files. Yeah, I will. So I will send it, Leonard. He will zip all these .dot class files and then create a zip file. Okay. But the problem is, if he uses these zip files, any of the zip utilities that we have today, these are operating system dependent, unfortunately. Zip might not work in Mac or Unix. Zip works in Windows and tar works in Unix. So we have the operating system dependent zip utilities. So Java's main goal from day one has been that operating system independent. Whatever it develops, it should be operating system independent. So it developed a simple zipping utility called jar, Java Archive. So using this utility, you can zip this and you can create a jar file, .jar file, like how you do a .zip or .tar. So you can do it .jar file. So this jar file is a component now. When you ask Gunjan, hey, can you give me your code? Then he'll give you one single file. That's .jar file. So it's a compressed class files. So it contains only class files. If you want to look at it, well, you can definitely take a look at that jar file. Just right click, open with, and then open with any of those zipping stuff. Oops, open with. Yeah, I open with. And then you say WinZip. Just click. Okay. See this? This is how it looks inside. This is the package. Org. Hamcrest is a package name. So org JUnit. So these are all the class files. See? After, assert, assume, before, class rule, test. There is a class called test. So all these class files, they wrote all these classes and then they zipped and then giving it to you as a single file. So now if you want to use any of these classes, you have so many classes, right? Calculator, overriding examples and everything. You can use this outside jar file also, like the classes that you wrote. There is no difference between the classes that you wrote versus the classes that you imported from internet. There's no difference. JVM treats everyone as the same. So, but all we have to do is we have to tell JVM that, please, my class files are here in this jar file. Okay, my all of my class files are inside this jar file. Please put this also in your class path. There is an environment variable called a class path. So remember on day one we talked about path. I know some people got confused. So that's totally fine. So when you say path, right, your operating system will look in all the locations that are defined in path. Similarly, JVM will look at all the locations that are defined inside inside the class path environment variable. So here you can specify all the jar files. So you can say that, hey, my classes are inside this one, junit.jar. Can you put them in your class path too? Meaning, when you run it, take them into consideration too. Hey, some of my classes are here also. Please use them also when you load it. That's all we are doing. So what we do here is, I'll get the jar file. Okay. I'll go to my C, Java training, projects, Core Java Venkat. And then here, I create a folder called inside the Core Java Venkat itself directly. Here I'll create a folder called lib, stands for libraries. All of my libraries will go here. So all the jar files will go inside this one. Well, just by putting the jar file there, your JVM doesn't know about this jar file at all. It doesn't. So you have to tell. Now come to your Eclipse. And now by default, you don't see the lib folder that we just created. What you have to do is select your Core Java Venkat and just right click, refresh. See, now you can see it. Now what you have to do is you have to put this to the class path of this project. So when you are running any of the classes inside this project, JVM will understand those libraries in the class path. So what you have to do is you have to put in builds class path for Eclipse. How do you do that? Well, right click on this project, go to properties. There are two ways to do it. And make it big. Okay. On the left side, there is something called Java build path. So when Java is building, what are all the jar files that you want to put them in class path so that your JVM will understand that. So go to library section, and by default, all of your JRE system library, see? So all the jar files that the core jar files that Java provides, see? Resources.jar, that's coming from JDK, rt.jar, runtime.jar, JSSE, JCE, these are all Java is giving you core. When you download Java, you get these jar files because you are using java.lang.string, java.util.date. All of them are there in one of these jar files. Okay. So what you have to do is similarly, we have to add our jar file also here. Once you add here, and that's all. When you run any class in JVM inside Eclipse for this project only, okay, then it will utilize all the classes. All the classes inside those jar files will be visible to that. So now click on add jars. Again, Core Java Venkat, lib, junit 4.10.jar. Just select this one, click OK. Now it is there too. Click OK. That's all. And there is a shortcut also. Right click, build path, add to build path. If it's there, then you will see that. Configure build path. I'll just remove it. Click OK. Now you see this one. Right click, build path, configure. Oh, there is no add to build path directly. Okay. Just right click, build path, and configure build path. You directly come here and you say add jars, and then go to lib. Yep, that's all. It's that easy. So now your JUnit library is inside this project. Okay, let me send this link to you, everyone. That's where you can download your JUnit. And by the way, this has been developed by Kent Beck. He's one of those agile people. Okay. Well, in Core Java Venkat, now what we do is we have added our JUnit. We are going to use JUnit framework to do our unit testing. Okay, how do we do it? How do we do unit testing? Let's go. Before we start, I want to tell you one more thing, and then we are good to go. One more thing is something called annotation. Okay. A simple concept in Java called annotations. These annotations have been added in JDK 1.5. And what are these annotations? Well, these annotations, when you write your Java code, okay, you can put some extra piece of information on your class or on your method or on your variables or on your constructors to give some extra piece of information either to your compiler or your runtime environment. Runtime environment is JVM. So you can give some extra piece of information. You can tell more about that one. So when you write a method called test add, public void test add, I'm writing a test case for addition. So here I'll say that I'll pass 2 and 3 and I'll make sure I get 5. Okay. So how do I tell that this is a test case? Well, you can do that using this annotations concept. So we used to do that differently before 1.5. What we used to do is every method should start with this test. That is how JUnit used to understand that one. Now, JUnit started reading these annotations. On your method, you annotate this with at test. All these annotations, they start with this at. At stand for annotation type, and they took the symbol at. So, annotation type test. So once you annotate your method with at test, then JUnit recognizes them as a unit test case. This is a unit test case, and yes, I have to run this guy. If you don't put it, it thinks that it's like any other method. It's not a test case. It's like a classes method. It's not for me. I don't care about it. So that's called annotations. And annotations give you some extra piece of information. And annotations don't change the semantics of your class. That's one thing you have to understand. Annotations don't change the semantics. They just add the extra piece of information to your class or method or your variable or constructor. But they don't change the semantics, meaning they don't change your method signature, or they don't change how you do it. Whether you have the annotation or you don't have the annotation, it doesn't give you any compilation error, but it behaves differently because your runtime environment, your JUnit, when your JVM kicks off JUnit runtime environment, and JUnit runtime environment will look for these annotations, at test annotations. But the concept of at is called annotations. So defining those annotations using at is called annotations. But whether it's at test or at Venkat, at something, we can write our own annotation types. We'll look at that later. But for now, these annotations give you extra piece of information to those who are interested in it. And your JUnit is interested in it, in these annotations, these at test annotations. That's all I wanted to say at this point. Okay, let's go. And I'll create a new package called unit testing. Right click, new package. Com training, Java core, unit test. Okay. So what I want to do is, first I will show you how to write a unit test for the existing class. First we'll write a class and then, test it. And then we'll step back and then test drive it, the same code. So I'll write a calculator class. At this point, we're all familiar with these classes, methods, and everything. So I'm going to say public int add. Okay, int a, int b, return a plus b. Right? When you add, that's how it works. Right? That's what it does. Public void subtract int a comma int b, return a minus b. Oops, public void. Okay. Public int multiply. Oh, very cool, right? I wrote a calculator, simple calculator. Let's write unit test case for that. Right click, new. It's like any other class, okay? So I'll call generally every test class, okay, ends with test, calculator test. Calculator test, finish. And now what I'll do is I'll write a simple method, public void test add. I'm testing adding functionality. It's a single method. It's very simple. Okay. And I'll call the calculator. I'll say calculator calc equal to new calculator. Okay. And say calc dot add. I'll give 213. I'll get the result. Int result equal to calc dot add 213. Now, if I want, I can print this. Sure. Right? So how we used to test all these while is like this. This is how we used to test it. Right click, run as Java application. See that result is 5. Oh, good. Result is 5. But how can I automate it? I can't look at the console every time and look at it. And when I change something in my calculator, maybe I messed up this test case. How would I know that? When I wanted to add a new functionality to calculator, I accidentally messed up my add functionality, and how would I know that? Unless I run the unit test case for that. Well, I run this again. And I have to look at the console, or I have to read the console. It's pretty crappy, right? And moreover, I can only have one main method in a class. I can't have more than one. So what would I do in that case? Well, that's where unit testing frameworks like JUnit comes handy. So this is how we do it. Rather than writing main classes and relying on those system out printlns, we have better tools in our hands. Public void test add. You be as explicit as possible what you are testing. Okay, very cool. And now all you have to do is you annotate this method with at test, like I just told you, at. Okay, and control space bar. It automatically gives you that. See that? arg.junit at test. So you are importing this class called arg.junit test. Importing that annotation type. In fact, this test is an annotation type, at annotation type. So they chose this symbol called at. So when you say at something, that's called annotation. It doesn't change the semantics of your class or method or anything, but it adds some more information to your class for those who are interested in those annotation types. Simple. Okay? Well, now all I have to do is, excuse me, excuse me. Sorry. So just by defining that at test, this became my test case now. So how do I run this test case? Right click, run as. Now automatically your Eclipse understands that this is a JUnit test case, and it gives you this option as JUnit test. So now you have to run it as a JUnit test. Just click on it. See that? All you did is it ran this method. You didn't put it in main. What did I tell you all this while? If you want to run something, you have to have a main method. But you are not running. It's being run by JUnit runtime environment that understands this at test annotations and understands this as a unit test case and runs it. So right click, run as JUnit test. And I say that, see here, it ran my method and I got these results. Okay. See, click here in the left bottom. See this one? JUnit test. So I got these results as I got the system out println, definitely, and then go here. Okay, see this one? Finished after 0.01 seconds, runs, it ran one single test case, and then errors, zero failures, everything is good. See that tick mark? Because nothing failed here. Well, we did not unleash the real functionality of JUnit yet. We only printed it. But how did it know it succeeded? Well, it did not fail. That's what it means. So what we have to do is we have to use this one. 2 and 4. We gave 2 and 3, right? So now what we do is we gave 2 and 3. We got the result. Let's make sure this result is 5, not something else. Okay? So how do I assert that? How do I make sure that result is what I'm expecting? How do I write that? Well, in JUnit, you can do that. What you do is, there is a class called test case dot assert equals. There is a method called assert equals. Test case has a static method. We didn't talk about static, no problem. This is how you call the methods on static classes. So there is a static method called assert equals here and the class called test case. So you just say test case dot assert equals, and what is your expected value and what is your actual value. So when you add 2 and 3, what is your expected value? Expected value is 5. And then what is the actual value? Well, actual value is whatever is stored in result, right? So now we are using the functionality of unit testing, the JUnit. So test case dot assert equals, right click, run as JUnit test. Ooh, it ran and it's all good. This is called famous green bar in unit testing. Okay. So, okay, this is okay, but now let's change it. Let's change the parameters. Or maybe the code is bad. When I say add A plus B, maybe I'm giving A minus B. Okay. So, see, my code is bad. When I'm asking, I said I'm adding, but I'm not adding. I'm actually rather subtracting. I'll get to your question in a second, Gunjan, okay? So, right click, run as JUnit test. Ooh, see that? It failed now. Failures 1. Okay. See here. JUnit.framework.assertion failed error. Expected 5. I'm expecting the result of 5 for 2 and 3, but I got -1. Well, what's the problem? Well, your code sucks. Calculator class is bad. Let's take a look at it. Oh, this is the problem. See? I accidentally put A minus B. That's A plus B. Okay, let's rerun it again. Run as JUnit test case. Ooh, very good. We got the green bar now. Earlier, what bar did we get? We got the red bar. Run as JUnit test case. See, this is famous red bar. So these two bars are very famous in unit testing world, green bar and red bar. That's what we call it. Okay. So the problem with code, let's go ahead and run this. Okay. Okay, adding functionality is so far good. And now I don't need to depend on system out. In fact, I don't need to put the system out. Just right click, run as JUnit. Very cool. I got the green bar. As long as I put my assert statements here, then I'm cool. That is the test case for add functionality. Now, let's add one more test case for subtraction. Let's do that. Public void tests subtraction. Okay. So this is a test case, right? So you need the annotation at test. Very cool, very cool, very cool. Now, what do we need? Well, we need to instantiate our calculator. We need to instantiate our calculator and say calc dot subtraction. I want to subtract 56, okay, minus 29. I should get the result, right? I should get 27. Calc dot subtract 56 minus 29 is 27, right? So I should get 27 now. Okay, I got the result, but how do I make sure? Well, let's use our test case class. Test case dot, this one has a method called assert equals. Then my expectation is 27. My expectation is 27. And my actual is whatever the actual one. Let's see that. I wrote one more test case now. It's related to the calculator again. Let's make sure. Now, every time we run, we are running every single test case. We are running this one, we are running this one. We are not running separately, and you can't run separately too. Okay? That's a good thing. We are doing continuous testing. It's very important. And small iterations you have to keep doing. We just learned the agile principles. Right click, run as JUnit test. Very cool. It ran 2 and 0 failures, 0 errors. Everything is good. See that? For test add, it's success. See that tick mark? Test sub tick mark. Now, let's make the subtraction fail. This time what we do is 56 minus 29, but our test case is bad. It's expecting 30. Okay? My test case is bad. JUnit test. Ooh. It failed. See, it ran 2 and then failed 1. 1 failed. Test add is good. See the tick mark? Test sub. Okay, what's the problem here? Well, expected 30, but was 27. Okay, let's go and look at the code. Expected 30. I'll immediately look at the code first. So, it seems to be okay. It seems to be doing what it's claiming. Let's come here. 56 minus 20. Hey, it's 27. Who is expecting 30? Come on. Come back. So in this case, it was a test case problem. Yes, Kunjan. If you want to see that result in your test case, you just do a system.out.println in your console. That's how it works. But in this case, in your test cases, you don't need to because you have solid test cases. You are testing the code without even looking at the console. You don't need to look at the console and determine. Your code is determining now. Right click, run as JUnit test. Pretty cool, huh? Okay, now let's do multiply. Test multiply. Okay. Calculator, cal C equal to new calculator, cal C dot multiply 5 times 6 is 30, right? Int result equal to, we got the result, and we say, in fact, you don't need to do test case dot, test case dot, test case dot, but we haven't talked about a simple concept in Java called static imports that was introduced in 1.5. That's why we are doing test case dot, test case. In fact, we didn't talk about static yet. That's why I'm doing. Okay, what is the expected one? Expected one is what? 5 times 6 is 30. And then actual one is whatever is there in result. Okay, right click, run as JUnit. All good. Hey, how come it's 2? 1, 2, there is third one. Well, this is not a test case. JUnit didn't think it's a test case. Why? Because we are missing that fancy annotation called @test. Right click, run as JUnit test. Very cool, very cool. See, it ran 3, 0 errors, 0 failures. Click here. Test add is good, test sub is good, test multiplication is good. Very cool, very cool. Well, that's how you run all the unit test cases, and that's how you make sure, and you try to run it very frequently. Make all these test cases as part of your continuous integration builds so that they run very frequently, and then you will verify the behavior very often. It's very important. Okay, this is unit testing one way. Okay, now what we do is, let's do in a TDD. Let's practice TDD. How we can do this using test driving. Here we wrote the code. What if my user wants only add? I wrote the extra code. My Agni principle, I'm not following it. Right? So I don't need this code, but I wrote it. That's not what Agile is saying. That's not what Agni is saying, right? Okay, let's create one more package. Com training Java core TDD. Now here, what I do is, before, what's the TDD principle? Before you write a single line of code, you write a test case. Not even a single line of code should go to production without being covered by solid test case. Simple. It's not simple to write. Okay, it's very hard in practice to stick to that principle. It's very hard. It's extremely hard. But try it and you'll get the results. You'll follow these best practices. Right click. So I'm not designing my calculator yet, but what I understand from my business requirements are they kind of need a calculator. Okay, I don't design calculator. I want a test class. So I'll say calculator test. So I start with my test case. I have a test class. Now I'll write my test case now. So public void, what did she say? She said she wants to be able to add two numbers. Okay, public void test add. Okay, and actually in some cases this is a bad practice. Test add, it's not explicit enough. Your test case is not explicit enough. Rather, you use some good practices here. Here you say that adding 2 and 3 should give me 5. How about this method? Adding 2 and 3 should give me 5. That's more explicit. It's more readable when you say, rather than saying test add. Well, this is not more readable actually. If you put this underscores, it will be more readable actually. Okay, but I'll leave it like that. Okay, adding 2 and 3 should give me 5. Okay, so I have to add 2 and 3. For that I need a class. Well, I'll assume that there is a class. So I think the class name as calculator. I'll say calculator calc equal to new calculator. I don't have a class yet, but I'm assuming there is a class calculator, and say calc dot, shall I say add? Okay, add. Oh, by default it's taking from my other package, but that's not what I want, right? I wanted to create a different calculator actually. Okay, I did not create my calculator yet. Calc dot add, I said 2 and 3. Okay, and then I get my result. Into result, and say now test case dot assert equals my expected value is 5, and then my actual value is result. Okay, and I have to define this as a unit test case at test. Very cool. Now when you do TDD, the first thing you have to worry about is compiler. Okay, there is no class called calculator. So what do we do? Well, that's where we start. At least we have a test case that covers the scenario where it gives us 5 if we give 2 and 3 to calculator. So let's go ahead and build it because it's already failing. Let's go ahead and right click, run as JUnit test. Okay, proceed. See, it's failing. It's a red bar. So what TDD says is, let your test case fail first. Before you fix anything, let your test case fail. When you have a failed test case, that means you have solid coverage for that particular scenario. So first make it fail. Don't go just jump into it and fix it. Make it fail so that you have a scenario to cover that, and then now fix it. That fixing also, don't put the direct fix. Put very simple code to make that test case green, and then go back and refactor it. So it's a popularly known as red-green refactoring cycle. It's popularly known as red-green refactor. This is a cycle, and those cycles are very miniature. They're probably 1-minute cycles or a couple of minute cycles. So first you have to get the red bar, so make it fail. You quickly turn it to green by making a very small amount of code, and then refactor your code. Folks, can you hold on for just a couple of minutes? I'll just come back in a second. Okay, my son is crying. 1 second, please. I'll stop the recording. Just 1 second. So this is very popular pattern. So before you fix any bug, make it fail. I mean, this making it fail is a phenomenal concept. You have to understand the real concept behind that. When you get a production issue, right? you generally jump on it to fix it. Well, what they say is, why did it happen in the first case? If you really understand it, right? Why did it fail in the first case? Because we couldn't catch it somewhere downstream, right? We couldn't catch it during development. Okay, why couldn't we catch it? Because there is no test case for that particular scenario. Well, we understand that. That's why we got the issue. At least let us fix the system now. So it happened because there was not a test case to cover that particular scenario. So let's write a test case right now. So let's write a test case and let's make it fail. Making it fail is the most important thing in the TDD and unit testing and the whole agile. Don't just go and fix it. That's easy to fix it. Okay? But what happens if this happens? What happens if it comes back again? So you don't have that support. You don't have that safety net anymore. So put that safety net first. Put that test case. Your test cases are very important, right? That's very safety net. So you put that safety net first and say, okay, now I have a scenario. Now I'll make it fail. Now the test cases fail. Now you quickly make it green. Don't do the actual functionality, just whatever the tiniest bit of code that you have to write to turn it green. And then go refactor it. Once you refactor it, again red, green, refactor, again red, green, refactor. So you'll be in that cycle forever. That's how it works. So what happened here? We got the red. Now let's make it green. How? Well, there is a compilation issue. Come on, there is no class. Okay, let's fix it. Let's go. Let's use our quick fix, control-1. And then we say create class, calculator. See, we are creating a class called calculator. Superclass, yeah. Very cool. Finish. See, we have a calculator now. How about this? Okay, now let's go run it. Well, we have red again. Why? Again, we have a compilation issue. Okay, let's compilation issue. Huh? Let's do a quick fix again. Control-1. Create method, add interface. Very cool. Well, it'll be very tempting to say return I plus j. It will be very, very tempting. What's the shortcut key for import statement? Oh, importing is happening automatically here, but in general, what is the shortcut for import? You can do a couple of ways. Right click, right click, source, organize import. There is something called organize import, Control Shift O. When you do Control Shift O, all of your imports will be automatically organized, but use your Control space bar. See, when you do Control space bar like this, cow, okay, Control space bar. When you do that, com, training, Java, core, TDD, now, it automatically imports it if required. You know what I'm saying, Nandakumar? Did you get that? Use your test case, you know, if you don't have this import, right? So you don't have this. In this case, if you already have the code to do everything, then Control Shift O, organize imports, then automatically imports it. Otherwise, there is another way is you are writing right now, okay? Then you say test. You know the class name, right? Control space bar. Keep writing. See that? It's giving you automatically Control space bar. Okay. So it will be very tempting to write at this point, hey, add method is so simple. Come on, int I comma j. It will be very tempting. No, don't do it. Okay. At least we got this compilation issue fixed. Let's go ahead and run it. Run as unit test. Again, it failed. Why? Oh, this time expected 5 but was 0. Oh, okay. Now we have the compilation issue. We got that fixed, but the actual functionality is missing. Now, if I want to go to this add method directly, just press F3. It takes you to this class now. Okay, add method int I comma j. It'll be very tempting to say I plus j, but don't do it. What is our goal? Red, green refactor. Red and green. You have to have a fail test case. So what I want to do is, currently the test case is failing. Why is it failing? Because it is expecting 5. So what I do is, I'll say return 5. My test case will fail, will be successful now, right? Right click. Because this one is expecting 2 and 3, 5 is good. Run as unit test. Hey, good. My test case is successful now. Awesome. 2 and 3 is giving me 5 and my calculator is working. Very cool now. Now, is there anything that I'm duplicating here? Now I have to think about refactoring. Any duplication here? At this point, I'm okay. Here, anything I need to do refactoring? No. Refactoring is not changing the functionality. Keep in mind, refactoring meaning improving the design of the code by not changing the functionality. So we shouldn't touch the functionality. Okay? Your test cases should work after refactoring also. That's what refactoring means. Okay, my 2 and 3 is good. Now let's try. Public void. Now I'll say 5 and 8 should give me adding 5 and 8 should give me 13. That is my method. Okay, and it's a test case. Where are we now? Red, green, refactor. One cycle is done. Now we have to make it red before you write any code, right? Okay, let's write another test case. Okay, 2 and 3 is good, but does it mean addition is good? No, this is good. See, we hard coded here. So we have to make it fail. So 5 and 8. How do we do it? Calculator, calc equal to new calculator, and we say calc dot add 5 and 8. Int result. Okay, test case dot sot equals, what's the value that I'm expecting? I'm expecting 13, right? Result is whatever I get it from that. Very cool. Run it. Right click, run as JUnit test. It's a red bar. Why? Okay, the first one is good. Adding 2 and 3 is giving me 5. Adding 5 and 8 is not giving me 13. Expected is 13, but was 5. Oh, I'm expecting 13. If you don't know the result for big number, well, you have to know what you expect at any point, Mira, right? You know what I'm saying? You have to know the expectation for that. If you don't know the expectation, then you don't have the requirement. Very simple. So expected is 13, but was 5. Oh, okay. So I was expecting 13. So what should I do now? I have to change the tiniest bit of code to make this test case pass. I have to turn this test case to green. Yes, let's do that. Calculator. How do I do that? Just by changing this to 13. I changed it to 13 and I'll run it. Run as JUnit test case. Hey, again red. What happened? Well, this test case passed, but I broke the previous test case. See that? So this is red. Now you don't have any other option. Here you got 13, so this is good, but this is, now this failed here. The first one failed because you changed it to 13, but here you are expecting 5. What should I do? Now we have to think. Now we can't put hard code like 5 or 13. Now we have to do, okay, I'm doing add functionality. Now you come and say I plus j, because we have to turn that to green before you think about another test case or before you write another line of code. So you say return I plus j. Right click, run as JUnit test. Oh, pretty cool. Now I got the famous green bar. Now I have two 2 test cases, 0 failures, 0 errors, everything is cool. Awesome. So how do I write? Well, I need one more test case for this. So my 2 and 3 is good, 5 and 8 are good. Okay, now I have to test all the scenarios, right? So public void, I'll say test add for decimal numbers. I'm just saying I'm testing the decimal numbers. If you see something, actually before you come to this one, you need to fix something. Before you write the third test case, we talked about red, green refactor. After green, you see some duplication here. See this? Calculator, calc equal to new calculator, calculator, calc equal to new calculator. We did twice. It's bad. You have redundant code here. You need to refactor it and put it somewhere else. Well, I didn't talk about that concept yet, so we'll do that. Probably we'll do it today itself. Yeah. So calculator, see, I'm doing it third time. Okay. Ideally, we should do that refactor. So now what shall we do? Test add for decimal numbers. Okay, let's add decimal numbers. Int result equal to calc.add 5.5 and 3.2. And say test case, my result is going to be, what is this going to be? 8.7. Oops, 8.7. That's my result. That's my expectation. Well, right click, run as. I know it will fail. It's Eclipse itself is telling you. Or it failed. Why? Unresolved compilation problem. Calculator is not applicable. Okay, int and int is not applicable for the argument double and double. Well, see that? The method add of int and int in the type calculator is not applicable for the arguments double and double. So what do we have to do? Well, it's expecting int and int. There is not much we can do. Change. Now accept double also, because your business user said you have to accept. You have to do the addition for decimal places also. If you don't need this requirement, don't just go and add that. That's what Agni says. Okay. If you need it, you do it. You don't assume you would need it and do it. You should never do that. Okay. Hey, something else. What's the problem? Type mismatch, cannot convert from double to int. Again, we failed all the test cases with the compilation itself, because now it's giving you double. Well, double, double, and double. Very cool. Let's run it. Right click, run as JUnit test. Ooh, 2 test cases are broken now. We see this one. This is what happens. Think of this, whatever we are doing, think of it in a bigger picture. Every time you add a functionality, you think this is very, very tiny bit. Okay. But you accidentally will always break something else if you are not cautious. That's why having this safety net, having these test cases to support your functionality is very, very important. Then you will always have this. You can't go past this point. You added something, but you broke something. Well, what happened? Well, expected 5, but it was 5.0 because double always gives 5 points. That's 0, right? See, when you say 2 and 3, when you give it to double, it becomes 5.0. Okay? I change your expectation, or should change your logic. Okay. Actually, when you give 2 and 3, when you give an 2, let's go back here. When you give an 2 and 3, well, by default, since it is double, see, Earlier you had compilation issues. To fix that compilation issue, you quickly changed it to double. But because of this, you broke something else. You broke these two. What do you have to do? Well, 2 and 3 is double. So it shouldn't be double because here you are actually adding numeric numbers. So what do you have to do? You have to say int result. But you get the compilation issue. How? You typecast to int. And then let's leave it there and see what happens. Right click, run as JN. We want quick feedback. We are taking the same agile principle and putting here. There we are talking about 2 weeks. Here I'm talking about every couple of seconds. I want the quick feedback. Well, this test case passed now. Very good. See, 2 and 3. I typecasted because I know the value inside that is going to be int. And I'm comparing with 5. Very cool. Same case with 5 and 8. I know the value is int here. So go ahead and cast it, guys. And say int 5 and 8. Right click, run as JUnit. Ooh, all 3 test cases are passed. If you want to test for negative numbers, go ahead and test it. You put one more test case, and that's how you do rock solid. That's how you write rock solid test cases. You would think writing 3 or 4 different test cases for this simple method is too much, but never think that way. You always write more test cases, more code for your test than actual code. That's very common because you want to test every single scenario. So you want to test every single scenario. You want your code to be bulletproof. So now with this one, we only added add all this while. If you don't need subtract functionality, don't even add. Hey, do you have a test case? Ask your business user, hey, do you need subtract functionality? No, not right now. Then just check it in. That's all. Because when she says subtract functionality, then you write test cases first. You don't write a single line of code without having a solid test case. Simple. And you make it red first. Then quickly make it green with a single, the tiniest bit of code, and then come back and refactor it. Make another test case that fails the other scenario and then fix it. It will be very tempting to just go and say, hey, I minus j. No. Write every single scenario and write the test cases for those corner cases. Okay. That's all. So you don't write any line of code that's not being used in production if you follow these approaches. Test-driven development. This is what that one is. Red-green refactoring. So there are some fantastic books on unit testing, test-driven development. Buy a good book, and it's you are expected to know, and that's why I'm teaching this early on, so that you will have enough time to practice this. And all the agile principles, you have to embrace them, and they're expected to be asked in interviews. And this whole JUnit and test-driven development, people expect you to know these things, and people expect you to be hands-on as well before you join any company. I mean, seriously, if you look at it, not all people teach this. This is something. It's I mean, as I always tell you, it's my passion. I go to various conferences, and every year I go to various development conferences. I participate in the TDD practices. There is something called code retreat, okay, where people just go there and just code it. They take some simple problem to solve. Always take a simplest problem to solve, like calculator, or simple, take some shopping scenario and say, okay, movie rental scenario. That's what Martin Fowler took in his refactoring book. Take smallest problem, but always sharpen your skills, coding skills. Coding is like any other skill. You practice more, you'll be better at it. They say that in karate, apparently, if you want to master one particular step, okay, so you do that step like 150 times, 200 times. You just that one step itself, one particular shot maybe, okay. So that is called kata, K-A-T-A, kata in karate. So some people have brought that term into coding and they call it code kata. So take very tiny bit of problem, you try to do it differently. You did this way this time, right? Now you pair with a different person and do it differently. Always try to do pair programming. It's expected to do as well. You have to be familiar with it. And people don't look at how smart you are. People look at how team person you are. How well you can get along with other people. How, what's your interest in helping others. They don't look at, really smart people. One smart person can spoil the whole team as well. If you're a super smart guy and don't go along with the team, then you're bringing down the productivity of the whole team. So that's why you ought to be a team guy, team person. Always try to help others, and that's how you always step up in your team. Okay, I mean that's very important. Mentoring skills. That you have to get it. So it's a general talk. Well, red green refactoring. I mean you have to read lot. I can send some blog posts probably and something that I find in internet. Any questions at this point? My challenge to everyone is don't use public static void main from here onwards. Try to replace all main methods with the appropriate unit test cases, because you have to practice this skill from day one. From here onwards, you have to keep writing test cases. You have to be good at it. Okay, I mean, there's no shortcut, unfortunately. The practice is the only way. Okay. That's about all the agile techniques, unit testing, TDD, all that stuff. How is everyone doing? Was it interesting or it's boring?
It's a very good topic and very important.
It's very good topic, very important. Absolutely. You need it.
Yep.
Absolutely you need it. Simple. And if you talk about it, if you go to any of these conferences now, people talk about it. I mean, this is an upcoming thing. Of course, it's been coming up for the last few years. So you need it. You need all the tools, But unfortunately, you just have to keep doing it. Keep exercising. So you guys followed the concept? You got it? So you want to practice? Very cool. So I wanted to talk about the other stuff like static and probably static imports. So can I talk about another 10 minutes? I'll talk about static, probably 15 minutes. We'll talk about that one. And then do you want to meet as a team for the rest of the, 30-35 minutes? Is that okay? I'll just leave this to you guys. You talk about whatever you want to talk about. If you have any issues, Leonard and Mira were having issues, so you help. Okay? Is it a good idea?
Yes.
I mean, how come you are so silent? Huh? Every one of you. In my other batch, there is a guy named Jitin. I'm really missing him. He always disturbs me in between. Please disturb me. I told you several times. So do you have anything to talk about? Anything else? I am ready to talk anything. No?
Hey, Venkat, can you
Yeah.
show that the shortcut key import statement again, please?
Okay. What is that, Nandakumar? Can you tell me again?
You told already, I already asked me, you already showed me once. Can you just show me one more time just how to use the shortcut key for the import statement?
Absolutely. Absolutely. So now let's be specific.
I'm basically looking for this test case, like how you wrote the test.
Okay, the test case one. Okay.
Yeah.
See, I don't have a test case here. I don't have a test case here. I don't have a test case here. Okay. I don't even have this import. That's how we start.
And even the test as well, like you said, annotation test. Yeah, that's
Sure.
one. Yeah.
Yep. No problem. Let's take out. Okay.
Yep.
In Java and any other programming language, actually, if you look at Visual Studio does exactly the same thing. There's something called code completion. Okay. So what you have to do is here, you just start it at test, right? Then at ye. Now I want the code completion to help me with everything else. Control space bar. Control space bar. Then it helps me. So the moment I select one of these, what do you want? You want tested or test? You want test.
Mm-hmm.
Select test and then press enter. It does two things. It completes this one, and whatever is required, it will import also.
Oh, okay.
You know what I'm saying?
Yeah. Got it.
So, and the same thing here. At T itself, sure. Of course, you got more. You want theory, you want target, what do you want? So you have a lot of options, right? So you keep typing, it will help you. Okay?
Mm-hmm.
At test. So I want this one. And same thing, control space bar. It's called code completion. Okay? And now the same case with test case. Test case dot assert, what did we say? Assert equals. Did you get that?
Yeah. I'm getting it.
See, again, result, right? I don't want to type the whole result. Just say control space bar. It gives me all of my variables also. My variables also it gives me. Eclipse is smart. Of course, your Visual Studio is also smart. I'm not saying that. So you use Visual Studio, Nandakumar?
Yeah, I use Visual Studio.
Yeah, you have the same concept?
Yep.
That's how it works. Yep. Which one did you like, Visual Studio or Eclipse?
At this point, Visual Studio, because I'm still not used to this one.
Yeah, I know.
Maybe after a while, then I will.
Oh yeah, Eclipse is pretty cool.
Okay.
Yeah, I mean Visual Studio is really good too, actually. Okay, let's talk about Leonard's issue. Fail to load Java HL library. These are the errors that were encountered. No library one. Yeah. Did you all read the error that Leonard was getting? So Java HL library. This is one problem with that subclips plugin, Leonard. Okay, this is mainly problem with subclips plugin. So, but is it affecting you actually? You had the same error, yes. But it shouldn't affect you. It should still work. Java HL library is not part of your subclips plugin. So they leave it to you guys like if you read that error, in their website, actually what they clearly say is that, well, we are not responsible for Java HL stuff, we don't push it and all that stuff, okay? So there are two ways. One is, there are two ways to fix it. Help in your dashboard, if you look at it. Oh, by the way, this problem, you will run into this problem only in 64-bit operating systems. You will not get this error in 32-bit operating systems. If you shouldn't. In your extensions here, when you did subclips here, okay, of course now it's installed, but before installation it will show you the subclips. So until subclips 1.8, before 1.8, Java HL was not part of it. So you have to get it separately. What you have to do is, for that you need to get the subversion software on your own. So there are multiple subversion vendors. One of them is called Silk Subversion, Silk SVN. So what you do is, you go to the silksvn.com and go install your Silk SVN. That comes with the appropriate Java libraries, Java HL libraries. So install the Silk SVN 64-bit edition. You should be all taken care. You don't need this one. For 32-bit operating system people, you don't need this. But 64-bit, you need one of the subversion repository. So either Silk SVN or there one more called Corbanet, I think, or CollabNet. So there is CollabNet has one more subversion. So Silk SVN, you install one of this and then the error will be gone. It should not affect you. It should not affect you actually. So it will throw you that error, but it will still let you do whatever you need to do it. But if you want this error to be gone completely, install this Silk SVN. And I'm sure that's your 64-bit operating system, right? It doesn't happen in 32-bit. This is for everyone. In fact, earlier, for the previous batches, I used to give the instruction that, clearly first install Silk SVN and come here to subclips. But later on, in the later versions, they started pushing along with the subclips. What else? Yep, I know that. We'll talk about static quickly, and then, static methods, static variables, and then static imports. And then I'll just leave it to you guys. It takes 10 minutes. And then you talk if you want to among yourselves and then discuss. Okay. There is an important keyword in Java called static. This is what I want to talk about. So Java is an object-oriented programming language, and as I told you on day one, everything is an object here. Everything is an object here. So when you have a class, you instantiate it, you get the instance object. So as I told you, all these objects are actually stored in a separate space called heap inside your JVM. So JVM will share some of the memory that your computer has. You can configure that using your startup scripts. When you start the JVM, you can say that, okay, take 1024, meaning 1 gig of RAM for this one, 1 gig of memory for my whole JVM, but out of which some of will be used by heap. Okay, this is where all the objects will be residing. So you talk about car, right? When you say car C1 equal to new car C2 equal to new car, C3 equal to new car. So then you will have these three different objects in heap. Okay, C1, C2, C3. But the actual references, these C1, C2, C3 are handles, right? These are all objects, but handles are actually stored separately outside of heap. These are handles. This is C1 handle, C2 handle, C3 handle. So these are actually not stored on heap. In fact, we don't know. That's JVM specific. And Sun JVM, it works one way, and IBM JVM, it works another way. So we don't care about it. But all the objects are actually stored in heap. And C1 points to this guy. C2 points to this guy, and C3 points to this guy. So if you want to talk to this object at all, then you need handle. This is called reference. So if you want to do something like C3.drive, then you are communicating with this object. But if you want to communicate with this object, you need this remote. This is remote, object reference. So you do that on C3, and then this actually will do it. This is like a remote for this object. Okay? And each object, as you see here in heap, each object will get its own memory. When you instantiate it, all of your instance variables are fields, right? All these instance variables, state information, are fields. So they get memory allocated in heap. This is for C3. Okay? So memory gets allocated here. And then for C2, memory gets allocated here. So when you talk about instance variables, those are instance specific. So C3 instance variables will not be shared by C2. C2 instance variables will not be shared by C1. Each instance get its own memory. Okay? And C3 will not be able to see C2. C2 will not be able to see C1 or C3. And this is my object. Makes sense, right? I mean, using car is a template. Using the template, we are creating an object. And your Ford Focus has no clue about the Toyota Camry. When you're creating two different instances, have no clue, right? Makes sense. These are instance specific. Your Ford Focus is one instance and Toyota Camry is another instance of the same template called car. Well, this is good, and that's how we wanted it to be. In some cases, what if you want these variables to be class level, not instance specific? I want some piece of information to be shared by all these instances. What's the example? For example, I have this class called car, right? So it doesn't matter how many instances are created. I want to hold a variable that holds the number of cars created so far. Number of cars created so far. It doesn't matter whether it's a Ford Focus, Toyota Camry, or another instance. It doesn't matter. I want to know at any point how many instances are created. Obviously, that kind of information should not be inside this object itself, right? The reason is this guy is not visible to the outside world if it's part of instance. So you need something else in a bigger scope. You need at the class level, which is visible to all these instances, and every instance should be able to modify that. Those are called static variables. In some languages, these are called global, like in C++. These are called global variables or global methods. Okay, and in some or all languages, these are also called class. These are not instance variables. These are class variables, meaning they're actually tied to the class definition itself. The class definition is actually stored somewhere here in a different space called PermGen. This is my class. This is my car information. This is the template. Okay, out of this template, multiple objects are created here. Makes sense? But the static variables are actually stored outside of the heap here, and this is visible to every single object of this guy. So what I'm saying here is, practically, if you look at an example, you'll understand. What I'm saying here is, oh, static is a keyword, right? I'll say that I'll create a car. Okay. And I'll say so I have a constructor that takes when, make, model. Okay. Okay. I mean, you can do get, all that stuff. Okay, very cool. I'll say static demo. The point is, all these instance variables are instance specific. Car variables is visible to within the class and subclass, right? No, this variable is only within the class, not even subclass. This is private. It's not visible to the subclass also. For subclass, different rules. What is that? Protected. So now I'm creating car. I'll get to that for me in a second, okay? You have but I appreciate it though. I mean, you're trying to disturb me. Thanks. Okay. So these instance variables are instance specific. So when I say win number 1, 2, 3, Ford, Focus, okay, I got this handle now called Focus. Once I say focus.get car, once I say get car, get make, get model, only getters, I got the getters. So when I say, get when, I get this when, get make and get model, I get this one. These variables are not shared with this instance, and this instance has a different set of variables. These are instance variables. 9876 is the VIN number, Toyota, and Camry. So they are not shared. So these variables are not shared with this instance, and these variables are not shared with this instance. I mean, that's exactly how it should be, because they both are, though they both of them are derived from the same template, they have their own characteristics. That's what the state is. How about this one? I want to know, it doesn't matter what instance it is, what instance it is, but I want to define a variable that holds int number of cards created. Okay, so when a car is created, obviously that happens in the constructor, right? That's when the instantiation creation construction happens, right? So here I'd say number of cards created plus plus. So I'll change it. Oh, that's the shortcut, Gunjan? The getters for that one? Sure, I'll show it to you. Right click, run a source, generate getters and setters. Here you can say select all, you get getters and setters. But you can also select, just say select getters or select setters, deselect all, select getters. You know what I'm saying? That's how you get this. Anyways, no problem. When a car is constructed, I'm just incrementing it, number of cards created plus plus. So every time this constructor is called, I'm incrementing this number. Okay? Now I want to do something here. What is this? This is also an instance variable, right? At this point, this is an instance variable. Okay, let's see. This out. So number of cards created. I have to say, unfortunately, focus dot. This one yeah, number of cards created. Very good. So number of cards created equal to 1, number of cards created equal to 1. Why? I actually created 2 cards. The problem is this second guy doesn't know about this one. Every instance will get a separate copies of these instance variables. If you want a particular variable to be shared across multiple instances, in fact, it's not tied with any instance. Rather, it is actually tied with the class definition, the template itself. If you want to do something like that, then you declare that it's static. Now you say static int number of cards created. And now you see what happens. See that? Number of cards created. After this one, you called it. You got 1. Now you got 2. Now, what did we declare this? This is now a class-specific variable. This is not instance-specific. It's not going to be stored in heap at all. And every instance does not get separate copy of it. Every instance gets separate copy of these 3, but not this one, because this is actually not tied with the instance. This is a static. It's a global. It's a class level. And the point is, you can call the static variable directly on the instance, but this does not make sense because this one is not specific. This variable is not specific to instance now. This is actually classes property now, templates property, not instance, objects property. So you can do this one, but this is very discouraged. That's why this warning, see this one warning? The static failed card at number of KLs should be accessed in a static way. This is how you access all the static variables.
your class name dot your variable, car dot. See, this is the first time we are looking at it. Your class name dot variable. Wow, there is no instance there. There is no instance. There is no such thing called instance now. Car dot number of cars created. See this? You get the same result. Number of cars created 1, number of cars created 2. So for this kind of purposes, you have to use static. Something that you don't want it to be tied with the instance, that's when you want to use static. For the counters, number of cars created, you should use static. And all the utility methods, you should use it. If there is no state information at all, only behavior, then you can use static. But keep one thing in mind. I told you so much about object-oriented programming, inheritance, abstraction, polymorphisms, interface, whole stuff. The moment you use static, that is not object-oriented anymore. Because object doesn't even come into picture there. It's not an object, it's a class thing. You can't use any of these object-oriented principles anymore. It's more procedural oriented. That's how we used to do it in C. So it's more procedural. It's not bad. It's okay to use them on some utility functions. This is called static variables. And now static methods are also the same thing. Now you can create the static methods also. So you can have static methods. You can say public. I'll take your questions in a few minutes. And get number of cars created. Okay. Public static int get number of cars created. Now I can make this private. Private static. And I'll say return this. Oh, I have 2 of them. Sorry. Okay. Public static int get number of cars created. So you can use static methods also. Again, these methods are not being called on in any instance. In fact, they are not the property of instance anymore. They are the property of the class itself. When you call them, this is on the class itself. So instance agnostic, no more instance specific. This is on the class itself. And generally the static methods are used to return or to set the static variables, to play with the static variables. And now you can make this static. And now you can say that this one, all the static methods are also accessed like your variables directly on the class itself. There is no instance required. In fact, that is highly discouraged to use that. Very cool, right? And the other one is, this is about static variables and static methods. In fact, why wanted to, yep, see this here? Test case. There is a class called test case. Test case dot assert equals. So I'm calling a method called assert equals on the test case. And this assert equals is a static method. How would I know? Well, I didn't say test case t equal to new test case and t dot assert equals. I made this call directly on the class. That means that is not instance specific. So where would you use the static methods on a day-to-day basis? Well, you would use the static methods if you have utility methods, like something like this. Test case dot assert equals. This is just a utility methods and there is no state information there. You don't need it. In that case, it makes a lot of sense to use static methods. See, in this case, in our car example, I want this get number of cars to be created. When I call it, I don't want to be instance. In fact, I don't need to create an instance to call this one. all I want to know is I want an utility method that tells me how many cars are created so far. Come on, tell me. The car template, how many cars are created so far? Just give me a number. So that kind of utility methods. There is a class called math, java.lang.math. There are some, that whole class has only static methods because all of them are utility methods. There is no state typically. You just give me something, I'll give you. Math.random, for example. So give me a random number. You don't need to create an instance. Unnecessarily, you are creating an instance in the heap area. Why? You don't need it. All the statics are actually loaded only once in one of this area, and then they just keep, you can keep using them. You don't need a separate instance to call this one. Every time you create an instance, you are eating up memory. You are eating up memory. You don't have to eat up memory for this one. Okay. Okay, a lot of questions. Now I'll take one at a time. I'll go in this order. Okay, let me unmute Nandakumar. Nandakumar, can we have super class with only global variables? What is the question actually?
Actually, I take it back, Venkat. I got the answer actually.
Wonderful.
So ignore my question, please.
Wonderful. Because object-oriented principle doesn't even come into picture when you talk about static, because there's no concept of instance there. Tom, how would you keep track of number of cards created without use of statics? Without use of statics, you cannot, because instance variables are instance specific. So every time you create an instance, all of these instance variables are initialized.
Right. So you can't create the program 100% object-oriented.
No, you can't. Meaning, if you want these utility methods, no, absolutely. Because think about it, Tom, let's think this way. In an object-oriented, okay, there's no concept of static. Because once you create an object, you are getting your copy of instance variables. But here you are talking about the number of cards created, meaning you want something on top of all these instances. So we are talking two different things here. You know what I'm saying? Hello, Tom?
Yeah, okay. I understand. So
did you get that?
Well, so if you did want to make it 100% object-oriented, you'd have to create a class on top. And every time you created an instance of a new car, keep track of it in the superclass.
No. I'm not following that one. No. Can you repeat it, because there is I felt that there is something wrong in what you said.
Well, I guess my question is, if you want it, or if you wanted it to be 100% object-oriented, you would have to have a class above to do that work.
Class above the instances. You want to get all the instances. You want to keep track of every single instance that's created, right?
Right.
Okay, and using the static is one way, but you don't want to use the static because that's not complete 100%. Well, complete 100% meaning only this piece is not 100 object oriented, but everything else is object oriented, right? Here. Right? If not, every time an instance is created, store that in the database. That's the best example. Store that in database. If you don't want to use static at all, store that in database, and at any point you ask that guy, and that will go grab from the database and give it to you. How about that?
Okay, and then that would be an object. The field of the database.
Makes sense, right?
Yes.
So all these objects, every single object will store that counter in database. Okay, Fami, static methods only work with static variables. Static methods only work with static variables. Absolutely. There is a rule actually. Thanks. This is great point because the reason is public static can't get number of cards created. If I don't explain this, you'll get confused. Let's try that. Public static can't get number of cards created written when? One, luckily your compiler itself doesn't let you do that. Your static methods cannot access non-static variables. Simple reason is because these are all instance specific. They are all sitting inside the heap here. Okay. How can you access that? Because that is instance specific. Which instance are you talking about? When you say when, you are talking about there are 1,000 instances and each one will have a different when. What are you talking about? It doesn't make sense at all, right? That is why, luckily, compiler will not let you use that. So, static methods cannot access non-static variables. And this is generally if you write one of those SCJP exams, like Oracle Certified Developer, Java Developer exams, kind of. This is one of the questions. This is one of the areas that they test. Did you get that, Fami? Yeah, Nandakumar, you're saying, are we use a text file to store it? Absolutely. Use test somewhere outside of your program was my point. Okay, it's not. You store it in the database. You store it in test, wherever. Oh, by the way, if you want to know, just to answer these guys' question here, actually, once a car is instantiated, you are creating this static. The static is actually stored in JVM memory, okay? And you are incrementing that every time a car instance is created, right? Once JVM shuts down, your server shuts down, this value will be 0 again. This will be initialized when JVM starts. And it will be good until JVM is dead. Once JVM shuts down, once you restart your JVM, this will be 0 again. So that's why in all non-practical purposes, you want to store this in database or some text file, wherever it is. Database is a better place to get it. That's why for all non-practical purposes, so you may want to do it in database. Otherwise, if your JVM starts morning and if it shuts down in the evening, so if 100 cards are created, it tells you 100 cards. Next day, you ask how many cards created, it says 1. How come you have 100 cards created yesterday? Because the static variable gets initialized every time your JVM starts. Like your instance variables are initialized every time a new instance is created. Okay, Leonard, now let's go to you. Speak about the problem that you had yesterday. Gunjan also called me and he said he had issues viewing video, but later on he was fine. And I had no issues. I'm just opening up with everyone. Did you have issues, viewing the video yesterday? Anyone? Let's go one by one. Fami, did you have issues?
No, I haven't. It's good.
Okay. Bala, you managed to view it? Kulsum, you had no issues?
No issues.
Meera, did you have issues?
No.
Nandakumar, did you look at those videos?
Yeah, I looked at the video for first 5-10 minutes it was not showing and afterwards it started showing. So I thought probably it's the downloading time probably.
Yeah, exactly. It's buffering, right? It's obviously it's 400 meg. We are talking about 2-hour big movie. Shiba, did you run into any issues? Or Tom, did you run into any issues at all?
No, but that was the class, Wednesday's class? Yeah, no, I had
no issues. Okay, Leonard, do you want to share what you are facing actually? Can you talk about it? Hello, Leonard. Okay. Yeah, maybe he left. I don't know. That's all from my end. That's all for today. Static variable, static, methods.
Venkat,
Yes, Leonard?
yes.
Mm-hmm.
I could see like I had some problem with viewing the last video. Like I don't have.
Okay. Did
like,
you have problem viewing the other videos also?
No. The other
Only
videos were okay, but here I could hear like your voice, but I didn't see anything.
I don't know. Something was going on your end, Leonard, because none of us had issues. In fact, I tested it at least a few times.
But I could see previous videos.
Right.
No?
I don't know. We can take a look at it. I'll work with you probably on that. But
Venkat, I think the problem is the plugins of the browser. Ask him like which browser is he using. That can be one of the problem.
okay. Which browser are you using, Leonard?
No, I'm using Firefox, but I could see the previous video on the same browser.
Okay.
Sometimes it's maybe internet problem also sometimes.
Can you try now?
Right now, yes.
Okay, let me stop the recording. In fact, I'm done with my class. I'm going to stop the recording.
Wait, Venkat, do you have any homework or anything for us to do till Monday?
Yes. Let's talk about the homework. I'll put it in a proper way. I'll send it to you in email. But what I want to do is I want you to practice this unit testing. Finish the complete calculator on your own. Create a class calculator. Okay. And do the calculator test. Write unit test case for every single method in calculator. And then this is one exercise. The same set, calculator and calculator test. Do it with TDD practices this time. Don't write single line of code without writing a test case. So do the same test. Whatever I did in class exactly today, you do it at home. One more time on your own. In fact, that's all. It's mainly
what is TDD stand for?
Test-driven development. Test-driven development. Remember, we test drive it. We created the test class first.
Right.
You know what I'm talking about? We wrote the test class first, and then red-green refactoring. First, we made it red, and then quickly changed something, and then made it green. Immediately fix it. Like that. It's very important concept. Okay, let me stop the recording. And
Can you just repeat one more time, like create class calculator? Yes.
You're talking about here?
Yes, about like homework.
Yeah. Okay, what I'm saying is this is one set. First, what you do is create the calculator functionality completely. Write add, subtraction, multiplication, and division, and then write the unit test. I'm saying test after you write the actual functionality and feel how it is. Now, I want you to do the same thing again using TDD, meaning don't create the calculator directly. First, create the calculator test, write the test case first, and then let test case drive the actual code.
Okay. And I have like a question about this TDD class, because like for example, we didn't implement any functionality in add method. Like I would say a plus b, or something. Yes, only like we implemented only like 3 plus 5 and not a common functionality. In TDD class.
Yes.
What is it?
I'm not getting the question completely.
No, just can we go to TDD and to calculator class?
Okay. You want me to do it?
Yes.
I did it. Go look at the video today. We did this in the class. I don't know when you joined.
I don't remember. Maybe we finished like this, but okay. And okay. After I will view video. Okay.
Okay. Yeah. I mean, is that question with everyone? I mean, is it a surprise? See here, we did TDD, right? We wrote the calculator test first, and then we wrote the test class. We got the compilation issues. Then we created the class. We got the compilation issue here. Then we created the method. So it's a test driving everything. This test class is driving the actual class, actual development.
Can we look at calculator class?
Yeah, that's all it has. But you are looking at it after the fact. Before that, we did so many iterations, Leonard. Here, 2 and 3 we did. We hard coded here as 5 first.
Yes,
And
I remember all these operations. Thank you.
Yep.
I remember all.
Wonderful. That's all the test, homework. And I'll send an email to you too. Can I stop the recording? Any other questions?
Got it. Thank you.
No, it's good.
Wonderful.